Lesson 2's workbooks, we're going to start with question 10 and work our way backwards. So, right here. Okay, question 10, quadrilateral ABCD with A at 0, 1, B at 1, 0, C at 0, -1, and D at -1, 0. Prove quadrilateral ABCD is a rhombus. Okay, so the first thing that I'm thinking is, well, what is a rhombus? And so I'm going to scroll up here to my key terms and I'm going to look for rhombus. Alright, so a rhombus is a quadrilateral with 4 congruent sides. So when I am trying to prove a rhombus, I need to prove that all 4 sides are congruent. All sides are congruent. Alright, so that's what my game plan is. So I need to prove that all of the sides are congruent. So I'm going to come down here, scroll down, back to question 10. Alright, so now we're going to read through this proof. Read the following proof for this problem carefully, then answer the question. So quadrilateral ABCD with A at 0, 1, B at 1, 0, and C at 0, -1, and D at -1, 0. That is a given. It's given right here. It even says it, given. Alright, so now AB is the square root of 2, BC is the square root of 2, CD is equal to the square root of 2, and AD is equal to the square root of 2. What is the reason? And they found the lengths of it. So in order to find the lengths, you have to use the distance formula. So blank 1, symmetric property, no. Blank 1, definition of a distance. Blank 1, the distance formula. Blank 1, if the diagonals of a parallelogram, no. So blank 1, they use the distance formula. So then 3, AB is equal to BC, which is equal to CD, which is equal to AD. That's true through the transitive property of equality, and that's because all of the lengths were the same. So line segment AB is congruent to line segment BC, which is congruent to CD, which is congruent to AD for the definition of congruence. Yes, because all of the sides are the exact same. So then 5, quadrilateral ABCD is a rhombus. And so we need a blank 2. What is the reason for that? So let's look at our blank 2. Blank 2, definition of a rhombus. Blank 2, definition of a distance formula. Okay, well, thinking back to what we had to prove was that the rhombuses had all the sides being congruent. So that's the definition of a rhombus. And we're not worried about the definition of a parallelogram because we're dealing with a rhombus, even though a rhombus is a parallelogram. We wanted to prove that it was a rhombus. So let's check those and move on. And says great job. All right, so now we're going to do question 9. Ulibri is working on a proof to show that a parallelogram with these vertices at A 0, 0, B at 3, 4, C at 11, 2, and D at 8, -6 is a rectangle. She already knows the figure is a parallelogram. Her work is shown here, but a few steps are missing. Read her proof carefully. Okay, so I'm going to hopefully have this in my notes, but if I don't, then I'm going to go to my key terms again, which I already had, and I'm going to go to a rectangle. Rectangle is a parallelogram, so rectangle is a parallelogram, and I'm parallelogram with 4 congruent sides. 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 4 congruent si 4 right angles. Alright, so that is what the definition of a rectangle. So let's go back to question 9. And question 9, it says that she already knew that it was a parallelogram, so we don't have to prove that it was a parallelogram anymore. We just have to prove that it has 4 right angles. So her work is shown here, but a few steps are missing. Read her proof carefully and then find it. Okay, quadrilateral ABCD is a parallelogram. That's given. A is at 0, 0, B is at 3, 4, C is at 11, 2, and D is at 8, negative 6. Given. Yes, it's given right here in the very beginning, right there. Quadrilateral is a parallelogram. BD is equal to the square root of 125. Okay, so what's the blank 1? I would say that blank 1, they found the distance of BD. So blank 1 is going to be the distance formula. So then you click on it and you drag it till the one that you want is highlighted and you unclick. Alright, so then blank 2. And the reason is a distance formula. So I'm assuming that they're finding a blank, and then blank 3 and blank 4 is left. And so let's read 6 for an idea. They're wanting us to find AC since they already found BD. So let's go back through here and find the distance of AC. So AC's distance, the distance formula is the square root of our horizontal distance, so our x values, 0 minus 3 squared, that is supposed to be up higher, squared, plus our vertical distance, and that's the difference between our y coordinates, 0 and 4. 0 minus 4 being squared, which 0 minus 3 is minus 3, or negative 3, being squared, plus 0 minus 4 is negative 4, and that's being squared, which equals the square root of negative 3 squared is 9, plus negative 4 squared is 16, and then 9 plus 16 is 25, so the square root of oh, hey, I just did all of this work for the distance of AB, which was not what we wanted to find. We wanted to find AC, and the reason I caught that was because I looked here for the reason definition of congruence. Congruence means they're the same, and BD is 125, and this came out to be 25. So I knew something was wrong. So let's try that again with the correct points, and I'm just going to erase from here down. Okay, so I do sort of like proofs because they give you good clues as to if you're even doing it right. So AC, not AB. All right, AC, the horizontal distance again was our x coordinates, so 0 and 11. So that should be minus 11 plus our vertical distance, which is 0 and 2. So 0 minus 2. 0 minus 11 is negative 11. 0 minus 2 is negative 2. Negative 11 squared is 121. Negative 2 squared is 4. And 121 plus 4 is 125. Okay, so AC is the square root of 125. So let's look for our blank 2 for AC equals to 125. Oh goodness. Sorry if you can hear my dog in the background. So we have blank 2. I'm selecting that. I'm looking for AC equals square root of 125. Click and drag to select that as our answer. And then blank 3 and blank 4. So we found that AC is equal to the square root of 125. So that means that BD is going to equal AC because they have the same value, distance value. BD equals 100 square root of 125 and AC equals the square root of 125. So that means BD is going to equal AC, and blank 4, that should be the transitive. It's when we connect them together. So we have transitive. So let's look for blank 3, BD equal to AC. So blank 3 or AC equals to BD. There we go. And then blank 4, the transitive property of equality. And that's what we said. And then it gives us step 6, AC is congruent to BD, and the definition of congruence. So parallelogram ABCD is a rectangle blank. All right, so how come it's a rectangle? So that means that it is it the definition of a distance? Is it because a parallelogram is a rectangle if and only if its opposite sides are congruent? We don't need any side lengths, so those two options are out. And a parallelogram is a rectangle if and only if its diagonals are congruent. So let's look. What is AC and BD representing? So let's draw this rectangle in our head. So we have A, B, C, D. Okay, and the reason why that's important is because it's the direction that you're going to label your corners. A, B, C, D. Okay, and what did we find? We found BD. So from corner B to D, we found that distance. That's a diagonal. So is AC a diagonal? A to C. Yes, AC is a diagonal. And so I would add that to your, it's not the definition of a rectangle, so that's why it wasn't included, but I would make note of it. A rectangle, it has congruent, it's a property of a rectangle, has congruent diagonals. And that should have been in your level up reading. And so that's why she went that way. It's because we haven't learned about how to prove that we have right angles. We will though. So I would definitely add that it has congruent diagonals into your notes. So blank 5, parallelogram is a rectangle if and only if its diagonals are congruent. All right, that's where we're at, and we're gonna check it. I like submitting it every time just to see if I'm correct before I move on. So there was question 9. All right, so let's run a what if scenario. Say that I accidentally clicked on one of these and I wanted to change that answer. You click on the whichever one you want. So blank 1, say I wanted to change that. I would click on it and then it unlinks it and it sends it back. So whichever one you want to unlink, you just click on it and it sends it back. And I don't remember. Blank 1 is the distance formula. So there we go. All right, so now we're going to jump to question we're going to jump to question 6. And we're going to see quadrilateral ABCD with A 16, B 66, C 52, and D 02. Prove quadrilateral ABCD is a parallelogram. So again, I'm going to look at the parallelogram. Quadrilateral with both pairs of opposite sides being parallel. Okay, and then this has to do with distances. So if we looked back into our concepts, concept C, quadrilaterals in the coordinate plane, that would be a good reference to go to because we are talking about a parallelogram, which is a quadrilateral. So say we had questions as to, well, what can a parallelogram have? So if a quadrilateral is a and it just happens to be the first one that pulls up, then its opposite sides are congruent. So I would add that into my notes. A parallelogram, opposite sides are congruent. So let's go back to our question 6 and see if it comes up with any plan like that. So opposite sides are congruent. So which plan for a proof for this problem makes the most sense? Prove one pair of opposite sides are parallel and congruent by using the distance formula and definition of parallel lines. Prove opposite sides are parallel by using the distance formula and the definition of parallel lines. Prove opposite sides are congruent using the distance formula and the transitive property of equality, and prove opposite angles are congruent by using the distance formula and definitions of angles. Okay, well, this angle one, I'm going to automatically eliminate because we haven't talked about angles. We talked about that a parallelogram has opposite sides that are the same. So being the same means that they are congruent. So prove that opposite sides are congruent, so the same, by using the distance formula. Yeah, we would use the distance formula to find out how long they are. That's how we would find out if they were the same length. And the transitive property of equality. The transitive property of equality is saying, like, if A is equal to 5 and B is equal to 5, then A is equal to B. It links these two together because they're both equal to 5. So if I want to prove that opposite sides are congruent or the same, then I would have to say these have the same distance. So say their distance was 5 and say this distance was 5. Then through the transitive property, I could say, well, this side is congruent or equal to this side because of the transitive property. They're the same. So that one makes the most sense. All right, question 5. Another proof. So given angle B is congruent to angle E, angle C is congruent to angle F, B is at -3, 4, C is at 1, -3, E is at 4, -3, and F is at 8, -10. Prove that triangle ABC is congruent to triangle DEF. That means that corresponding sides are the same side length and the angles are the same. So we have a few things for triangle congruence, and if you didn't write those down, if you scroll up here to your notes, congruent triangles in the coordinate plane would be a great place to look again. So concept B, if you didn't take very many notes, use that as a reference. So let's read through this. Angle B is congruent to angle C is congruent to angle F, B is at -3, 4, C is at 1, -3, E is at 4, -3, and F is at 8, -10. That is given. That's just all of the information that they gave us right from the get-go. All right, so BC is equal to the square root of 65, and EF is equal to the square root of 65. Blank 1. Well, it looks like they found the distance by using the distance formula. So blank 1, I'm looking for distance formula. And then, so you click whichever blank you want and you drag it till it highlights the side you want. So then BC is equal to EF, blank 2. And so I'm looking through here, side angle, side congruence postulate. No, it's talking about just two sides, not a side and an angle. So we have reflexive property of congruence, transitive property of equality, and side congruence postulate. So blank 2, the transitive property or the reflexive property, which one of congruence? Which one is it? Well, we have two things that are equal to the same value. So property of equality, that's a good clue there. I also know that the transitive property of equality states that if two things are equal to the same distance or the same value, those two things have to be equal. And so that's what it's saying. BC is equal to the square root of 65 and EF is equal to the square root of 65. That's the same distance. So that means BC has to be equal to EF. So that's our transitive property of equality. Blank 3, definition of congruence. Okay, so I'm looking for, with congruence, I'm looking for the equal sign. Congruence is represented by that symbol. So I'm looking for anything like that. And since step 3 just said BC and EF were equal to each other, I'm looking for a BC is congruent to EF line segment. So I'm going to click blank 3 and drag it to a BC is congruent to an EF. So that's BC congruent to FD, not what I wanted. BC is congruent to EF. There we go. Okay, so say for example I did click on BC is congruent to FD and then I realized, wait, that says EF. How do I undo that? You click on it and it sends the blank back. So then you would re-click on your blank that you want. BC is congruent to EF. And then we have triangle ABC is congruent to triangle DEF, blank 4. So is it the side angle side congruence postulate, angle side angle congruence theorem, or the side congruence postulate? So let's look through what we have. We have an angle here. Angle B is congruent to angle E. So we have an angle, and then we just proved that the side BC is congruent to the side EF, so we have a side. And then we were also given that angle C was congruent to angle F, so we have another angle. So that is the angle side angle. So blank 4, I'm clicking and dragging to angle side angle congruence theorem, and we'll check that 5 and 4 are correct. So submit for grading. Just to double check that 6 and 5. So 6 we were correct, distance formula and transitive property, and 5 we are also correct. It is the angle side angle. So there's our time, and if you would like to see any of these other ones stepped through, please email me and we'll set up a live office hour so that I can give you some help.